Okay. All right. So, if you think of, remember how this chapter started? You had two cones right on top of each other like this, kind of like that.
Yeah.
If you understand how conic sections appear, if I can take a flat plane and slice it straight through the conic, all you're going to see is what? A perfect circle. Okay. If I could slice it more of an angle, like maybe this, now you're going to see a what? Now it's going to be an ellipse. And if I could do it one more time, but I could do it perfectly vertical, like this. Well, what you're going to see is this side, and then you're going to see this side. Something like that, and something like this. And this is what we call a what? Hyperbola. So now hyperbola looks like a parabola pointing two different directions. Okay? Now, here's what you guys are going to cover. You're going to cover parabolas that look like this. I'm sorry, I didn't mean to say parabolas. Hyperbolas that look like this. You can have hyperbolas pointing left and right, or what's the other one? Up and down. So you'll get this look, or this look, one or the other. Okay. All right. First, what is a hyperbola? Well, everything had a definition. Parabolas had definitions. So did ellipses. So does the hyperbola. So on this slide, I think you should just draw yourself a quick picture. It says a hyperbola is a collection of points in a plane where the difference of whose distances from two fixed points, the foci, is constant. So the big difference here is this. When it was an ellipse, I don't know if you guys remember this, but the definition says in an ellipse, if you take a point on the ellipse, you take this distance from point to foci plus point to foci, you always get the same number. Well, in this one, it's just a little different. If I were you, I'd go like this, just draw a hyperbola that looks like that, okay? And what they're trying to tell you is this. Your foci, just like parabolas, will be inside the parabola, right there. Okay, so that is the same as a parabola. The foci hides inside. This point right here, guys, what are we going to call that? These 2 points. Yeah, that's the vertex. They're just parabolas pointing in opposite directions. Okay, so here is what this definition says. If you pick a point, any point on the hyperbola, and you take that distance from here to here, so point to focus, F1 we'll say, and point to the other focus, F2, well, what it's trying to tell you in the definition is if you take this distance, call that distance 2, call this distance 1. If you take the two distances and you subtract them, you're always going to get what? A constant number. And what's that constant number? Oh, who knows? It could be 5, it could be 10, 20. Okay? And that's all they're trying to tell you. Any point I can pick. I could say from here to here, and from here to here. Okay? So this would be D2 because it's longer, and this would be D1 because it's shorter to fit this. Okay? Does that make sense? Okay. All right. Definition. All right. Here is a picture of a hyperbola. Now they're giving names all over the place. Well, this might be the most important part of hyperbolas. It's called the what axis? Transverse axis. Now the transverse axis has everything on it. Just like the major axis in an ellipse, well, the transverse axis has everything on it. What's on it? Well, the two vertices of the parabolas, V1, V2. It has the focus, the other focus. It also has this. What do they call that spot? They call it the center, just like the ellipse. So there's so much that's the same. There's a little bit different there. Yes.
So like the distance from center to vertex is the same for vertex 1 and 2.
Yes.
Okay.
Yes. You remember how this was the minor axis in the ellipse? Well, they give it a different name. They call it what? They give it the conjugate axis. Okay. think of, you can think, oh, ellipses and hyperbolas are very much the same. They give them different names, but just try relate the two together. Now this, I'm telling you, is the most important thing because this controls your a squared. Remember a squared was so important to us in the ellipse. It's going to be important in hyperbolas. So what if I gave you this? What if I gave you a focus at 6, 0, and negative 6, 0? Where's the center? Yeah, the center is going to be 0, 0, but the center is what do you think the big word is? The center is the midpoint of the foci. And what else? The vertex, yeah. So if the book ever gives you a couple vertices, the center is the midpoint. If they give you the foci, the center is the midpoint. Okay. So I guess I should have said that right here. The center would be 0, 0. Okay. Good. Nod. Just nod. A couple nods. Yeah. Okay. All right. Next.
Might will update it.
Okay. Here's another hyperbola. The transverse axis. Is it horizontal or vertical? Okay. There you go. I want you to write this because I'm going to ask you that question a lot. So the transverse is horizontal, which will help us when we write equations. Okay. It can be vertical, but this one's not. All right. Here it says this. If you take 2a, well, hang on. We got to talk about a's and b's and c's. Okay. Now here's the deal. Come back here to the ellipse. If you look at my ellipse back here, guys, the a's and the b's and the c's stood for what again? What was a in the ellipse? Center to the what? Vertex. It won't change on you. It's going to be the same thing. Center to the vertex is going to be what? A. So that's not going to change. Okay. How about back here? What was it from? What do we call center to the foci? C. That's not going to change either. So if I go like this, center to the foci is C. Center to the foci is C. Okay. Now, this right here might be one of the most important things when it comes to story problems. It says here the constant difference from a point to the foci. So what they're saying here is this. If you take D2 minus D1, you always get this number. It's always constant. Okay? Okay. But that constant number is always going to be equal to 2a. What is 2a? From here, that's a, to here, that's a. So this is 2a. So the constant is always going to be vertice to vertice, 2a. Let me just show you something here. I'm going to go like this and this. Foci right there. Okay. If I pick a point on this parabola, this distance and this distance, if I subtract them, what am I supposed to get?
Constant.
A constant. Give me a number. Let's make it easy though. 9.
No.
Go even. Go even.
10.
10. Okay, let's call it 10. So you're telling me this minus this, D2 minus D1 is 10. Okay. So if I threw some numbers in, watch this. From center to there, from center to there. I'm going to call that 4, and then I'm going to call this distance right here 1 and 1. Okay. So if I did this, if I pick a point right here on the hyperbola, and I say, by definition, this minus this must be 10. Okay, now let's just check. Pick a point right there. What's the distance from here all the way to this focus? 9 minus this distance here to here. 1. We got 8. I should have had a 5, 5, 5, 1. I should have made those 5s. I should have made those 5s. My fault. If I'd have made that 5, 5, 1, that would have been 11 minus the 1, and we would have got our 10. I messed up on my numbers, is what I did. Okay? But from here to this distance minus this distance, we're saying it's 10. And if I put these numbers down, 5 plus 5 plus 1 is 11. Take away this distance, 1, and you will get 10. So what happens is basically this. 2a is always going to be the constant, whatever the constant is. Now we picked 10, so we've got to go with the 10. We could have picked 12. We could have picked 14. But 2a will always be the constant difference. Just remember that, not so much today, more tomorrow. Okay? And then I think there's some more down here, isn't there? Or am I wrong?
Yeah,
There's more? Okay. A, oh, I already did this up there. A is the distance from the center to the vertex, which didn't change from the ellipsis. C is the distance from the center to the focus, which didn't change. Okay? So we're okay there. Oh, okay, now they talked about B. Where is the B value? Well, the B value is actually the distance from the center straight up the conjugate. Or it could be down conjugate axis. So if I say B is 4, I'll go up 4. If I say it's 4, I'll go down 4. So it's just up and down the conjugate axis. Okay? I gotta look at the next slide. Just give me. Yeah. Okay. Here's the deal. If this is B, what's this right here? Yeah, that's A. Okay, and what's going to happen for you guys is this. You're going, in the next slide you'll see, you're going to make a box here. But in this box, I want you to understand, there's another Pythagorean relationship, and it happens right here, from the top, wherever B landed, to the vertex right there. This distance happens to be the same distance as that distance from there to there. What is that distance from center to focus? That's C. Okay, so there's your new triangle when it comes to hyperbolas. Remember this triangle up here? In the ellipse, this triangle brought this Pythagorean relationship, a squared equals b squared plus c squared, but you're going to get what out of this? What Pythagorean relationship is this? C squared equals a squared plus b squared. Just like you're used to, right? So the Pythagorean theorem goes with this hyperbola. But I mean, if you have to make a picture in your notes, not your notes, on your formula sheet, make the picture. This triangle goes with hyperbolas, where this triangle over here goes with ellipses. Okay? And you gotta know that, because this is how you get your A, B's, and C's. All right, next. With your A, B's, and C's, you're going to do this. Let me get rid of this. You're going to end up making a box with your A and your B. It says the points A units from the center, A units from the center on the transverse axis, and B units from the center on the conjugate axis form a box. Here's the box you'll form every time. You'll go this way for A, you'll go this way for B, and you'll see basically, and you can go backwards A, you can go down B, you can go all 4 directions and then just create your box like this. Okay, there's your box, and your box is going to come in really handy because of this. It says, on the conjugate axis forms a box, and the lines containing the diagonals of this box are asymptotes which the graph approaches. So really, the diagonals are your asymptotes. So we can just do this, run it right through the corner of your boxes, out, right through the corner of your box, out. And then from there, guys, you will just sketch it. You'll take your vertices, you'll already have them down. You'll run your hyperbola this way, and that's it. That's all I'm going to ask you to do is basically follow your diagonals out. All right? Now, here's the last thing I do want you to write. I want you to write the equation to both of these. So this diagonal has what equation? This diagonal has what equation? If I did something like this, does this ring a bell at all? What do we call this? Say it again. Okay, it's the point slope form of a line. And if you were asked to write the equation to this asymptote, because this starts at 0, 0, right? 0, 0 is the center. Then this would be y minus 0 equals your slope, x minus 0, right? Now, what's the slope of the line going to be? Look at the box. Can you tell me the slope of this asymptote? Did you rise how far? B. Did you run how far? A. Didn't you rise B, run A? So guys, if you know your B and your A, this will be really easy for you. I'll just say my slope is B over what? B over A. Now look at the formula of your equation. It says y equals plus or minus B over A x. Why is it plus or minus? Yes, and the other line has a what slope? Negative. So this is down B, negative B, over A, positive A. Okay? So this becomes your equation. And your slope is B over A. This gets a little more difficult when the center of the hyperbola starts to move around, like over 3 up 4. Okay? All right. Here comes your equations, just like ellipses. It looks almost the same. X squared over A squared minus Y squared over B squared equals 1. What's the difference? It's minus. That's the only difference right now. Okay. Now, here's my question. Why does A squared go under X here, but A squared goes under Y here? Right. It's all about the transverse. If the transverse is horizontal, A squared goes under X. If the transverse is vertical, A squared goes under Y. So here's a vertical. That would be vertical. And here's your horizontal. Okay, just so you know what I'm talking about. This is super important because you guys might get confused because you're thinking ellipses. It says here, in a hyperbola equation, A is not always the largest number. Do you remember me kind of hammering that in your head? A squared is the bigger number. Well, for hyperbolas, it doesn't matter. So you just have to say what? Is the transverse vertical? Oh, Y comes first. A squared goes under Y. If it's horizontal, A squared goes under X. And the order does matter. You cannot put X squared before Y squared, even though you might put a B there. Okay? If you did this, guys, would this work? Why not?
Subtraction doesn't work the same as addition.
There you go. Subtraction is very, like, it has to be one way. It cannot be both. Because if you went 5 minus 3, you get 2. But 3 minus 5, you get negative 2. It doesn't work. So the order does matter. So don't do this. That's kind of what this bottom little sentence is telling you. Okay? Order matters, okay? All right, we finally get to begin. Here we go. Look at the equation. Pick out your A, your B, your C. So what is A? What is B? What is C? A is what? 2. B is what? 4. How about C? Wouldn't it be this? Don't you follow this? C squared equals A squared plus B squared, right? If you want C, guys, C squared is equal to 4 plus 16. C squared equals 20. C is what? Square root of 20. Okay. Now, can I ask you this question? The transverse, is it horizontal or is it transverse vertical? I'm hearing vertical, is that right? Why? Because y is first. If y comes first, it's a vertical transverse, which means the hyperbola opens up and opens down, okay? All right. So we got this actually gave me square root of 20, okay? Translate these into coordinates and put them on the coordinate graph. Okay, in this form, right here, when it's just x squared, y squared, what's the center? Uh-oh, maybe I didn't say it. It did not say it. Okay, so the equation of a hyperbola, when it's in this look, has a center at what? 0, 0, yes. So when you get that simple look, it's just center 0, 0. Sorry, didn't say that. Okay, so your center would be 0, 0. Okay. Now, to get to your vertex of your two parabolas, what is it? A, B, or C? It's A. Okay, so I'll go where? Right to, left to, or up to, down to? Up to, down. Yeah, there you go. This is your vertex, this is your vertex, right? How about foci? How far up should I go? Square root of 20. 2 squares of 5, but where's that? 4 point something, right? If you type in square root of 20, I think it comes out 4.46 maybe. There it is, right there. 4.46 would be about here. Okay. And now you know your parabola, not parabola, you know your hyperbola should do something like this, right? Something like this. Okay. But you're not going to know how wide it is or how narrow it is until you... You what? Oh, sorry. Sorry, you're right. My fault. Sorry, I went too low, guys. Okay, but you're not going to know how wide to make this until you get this box drawn. So, from the vertex, okay, A is which direction again? What does A stand for? A is center to the vertex. You know what? I didn't put that down here, but I will. I won't. Come back here. Center to the vertex is A, right? Center to the foci is what? C. Center up and down the conjugate. Well, that would be B, okay? I shouldn't say up or down because it could be right or left. Okay. All right, so here's the center. Foci I got all. From the center of this, right here, I have to go A up, up A, okay, down A, that's 2 up, 2 down, I already did it. Now, on the conjugate, by the way, this is the conjugate, right? How far right and left are you going? 4. So you got to go 4 right, 4 left. 4, 1, 2, 3, 4. 1, 2, 3, 4. And this creates a box like this. There you go. There's your box. 2 up, 2 down, 4 right, 4 left. If you draw your diagonals through them, these actually become the asymptotes. Okay? Now, from the vertex, not the focus, because that's what I did, run your hyperbola this way, and this way, this way. Okay? All right. And then step 3 says, on your graph, create the box that will form the asymptotes. Then find the equation of the graph of the asymptote. Okay? I think I'm going to just show you the work behind this, and then after that, guys, I think you can kind of take off from there. If you want the equation for the asymptotes, always use the center of the box. That point is 0, 0. Since it's 0, 0, this will be really pretty easy for you. Using point slope form, it's going to be y minus 0 equals slope times x minus 0. But what's the slope? What's the slope from 0, 0 up?
Plus or minus 1/2.
There you go, up to over 4, which is really 1/2. And the work is so easy on this one, you probably say plus or minus 1/2 x. This one is actually y equals negative 1/2 x. This one is y equals positive 2x. There. Sketch the hyperbola, I already did it. What's really important is that you knew the transverse was vertical. Because if you thought the transverse was horizontal, you've got your hyperbola pointing the wrong direction. And it's all wrong. Questions? Nobody said it. Okay, here we go. Everything's about sketching. Get a sketch. Get a sketch. So let's do this. Find the equation of the hyperbola with center at 0, 0, focus at 3, 0, vertex at 1, 0. So sketch what they told you. Think about the transverse. Which way does it go? Right, left, up, down. Okay, right now tell me, the transverse axis is what? Horizontal. It's horizontal, which would mean to you, if it's horizontal, what comes first? X or Y? Yeah, X comes first, Y comes second, okay, and then a 1 out here, right? If it's horizontal, X comes first, A will always go under the X because it's horizontal. B goes under the Y squared, so B squared under here. Okay. Now, you should know it kind of does this little trick, right? Good? What do you know about ABC, though? A is what? Okay. Center to vertex, Peyton says 1, yes? No?
Yes.
Okay. What's B? Do you even know B? How far up?
Yes.
You don't see any box here, so you can't tell me B. But how about C? C would be here to here. Isn't that 3? Okay, remember how this triangle looks? It's A, this is B, and this happens to be C. So you have to solve for your B. So A squared plus B squared equals C squared. Since you know 3 squared is 9 and 1 squared is 1, B squared equals what? 8.
Square root of 8.
And B is what? Square root of 8. Okay. There we go. Good. Get your ABCs on paper, and then, what did it say? Write the equation, right? So if I write the equation to this parabola, it's going to be horizontal transverse axis. Which one comes first, X or Y? Then Y. Okay. Underneath the first variable you chose, X, is A squared. Square the A. 1. Square the B. That's just 8, right? Good. I don't need the 1 on the bottom. If you just want to say x squared minus y squared over 8 equals 1, that's fine. The sketch was just put on paper to help you see it. So many people are visual, so you got to do this. I mean, most of you have to do this, okay? Okay, what if the center's not at 0, 0? Well, that's just like ellipses. If the center's not at 0, 0, okay, so let's say it's here and here. This is the center, and we're going to call it h, comma, k, which all that means is instead of x squared minus y squared, it's going to be x minus h squared, y minus k squared, just like ellipses, okay? So the center does move. They gave you a quick way to write the equation of the asymptotes. There it is. Notice this. You will always use the center of the box as your point. The center of the box is always going to be the point that you write the equation with. So this is actually the equation to the asymptote. Y minus k equals plus or minus b over a, and then x minus h. Notice how it's b over a when you have a horizontal one, okay? But it's a over b when you have a what? A vertical transverse, okay? You know what though, guys? If I were you, I would not even memorize that stuff. I would just look at my box and then just write the equation. I really would. I think you'll be fine if you see what I'm talking about in just a second. Next slide. The center's going to move now, guys. Here it goes. The center moves to right there, -3, 1. Focus at -3, 6. Vertex at -3, 4. You might as well start, get going, sketch the information. Then I'll ask you a couple questions. Transverse is what? Vertical, horizontal? Vertical, yeah. Okay, so we got this vertical transverse going through, okay? Which tells me I know I'm going to go this way. Where's the other one? The other vertex, sorry.
3 down from C.
3 down from C. 1, 2, 3, something like this. Okay, vertex. Where's the focus? From here?
5 down.
5 down, okay. Okay, so I do know it's going like this, right? All right. And your job is to what? Write the equation. Find the equation of the hyperbola described here and draw the graph, so we have to draw the graph too. Is this going to be y first or x first? Vertical. It's a vertical transverse. It has to be y. Think x is left, right, y is up, down. So you better go with this one, y minus k squared minus x minus h squared, right? Equals 1. And then where's the a squared go? It's always going to be first. Whatever you put first, a squared goes under it. B squared goes here. Hey, does A squared have to be the biggest number? No, don't get hooked on that. That's ellipses, not hyperbolas, okay? All right, question, what's A, what's B, and all that? What's A? Center to what?
Vertex,
Vertex, that's what?
3.
3. What else do you know?
C is 5.
C is 5. Center to focus is 5.
And it's a triple.
And then this would be what then?
4.
And again, if you don't know what I did this. A squared plus B squared equals C squared. I'm not going to show my work. So you got a 3, 4, 5, A, B, C. All right. Just to write the equation, this shouldn't be too bad. I know the center is -3, comma, what? Up 1. So this will be y minus x minus. What's y minus? Always the center. 1. Okay, your center moved. And then x minus,
Plus
minus 3, plus 3. Okay, A is always going to go under the first one. A squared is what? 9. B squared is what? 16 with a minus in between. Okay, we now wrote the equation to the hyperbola, but it did say to sketch it. So to sketch it, you need the box, because the box will get you the diagonals. The diagonals are the asymptotes. So now, here I go. Cross this out, just erase that. Okay, here we go. A is up 3. B is what? Right 4. Right about there. Okay. Down 3, left 4. So there's the box right there that we were talking about. Okay. That box will create 2 asymptotes right through it's the diagonal, right through the center of the box. Keep going. And diagonal through here. Keep going. Which will allow you to do this. Just kind of treat those as asymptotes. We never get to touch them. Now what's the equation going to be? Well, what point are you going to use here? On this line, what point are you going to use? What's a good point to use on that line? Yeah, well, you're going after the slope. I'm just asking you to find me a point on your line. This point's on both lines. I'm using this point. -3, sorry, up 1. Okay? The slope of this thing, what is the slope? Yeah, it's up 3, and it's run 4, so it's 3/4. Now, for you to write this, it's going to be y minus, the center has a y value of 1. Slope is 3/4. X minus what? Which makes +3. Okay. You can slide the 1 over. Call it 1. And you'd have +3/4 x plus 3. Now what's the difference on the other one? If I did this again, what would be the only difference? It'd be, well, instead of going up 3/4, it's just what? Down 3/4. So couldn't I just do this? Couldn't I just say I can solve it once for +3/4 and once for -3/4? So the 2 equations are going to be 1 plus or minus 3/4 times x plus 3. This equation works for those 2 asymptotes. Now, do you want me to simplify all that? Probably not, do you? I mean, I can run this through and do all that work, but that's good, isn't it? Okay. Yeah. The 3/4 goes with the one going up, and the -3/4 goes with the one going down. Okay. Good. I got nods. Believe it or not, I got some nods, just so you know. All right. Uh-oh. What do you do?
Wait till the example gets done.
Okay. Doesn't look like the form we're used to.
Yes.
So what do we do? Complete the square. Complete the square. So go ahead and complete the square. Let's get started. Let me see what you do. What letter did you go with first? Did you write x squared? Or did you write y squared first? Because remember how this works? It's supposed to be the positive number minus the next number. Is which one's positive? X squared or y squared? Y. You had to do this, guys. You had to go y squared first plus blank, followed by what? X squared second. X squared second, and I would go plus negative 4x squared minus 8x plus blank. I'm going to move the 4 over here and call it what? Call it 4. Okay. So it's kind of like saying this group plus this group, right? So now complete the square. Half of b, cut it in half, square it. What do you get? Half of negative 4. Square negative 2, you get 4. Add 4 to both sides, right? Okay, what about the next one? Yeah, you know what? You want that to be x squared. You don't want negative and you don't want 4. So factor out what? Yeah, the negative. Get the negative out of there. And then you get this, and you get this, plus blank. What's half of 2 and then square? Half of 2 and then square it. You get what? You get 1. You put a 1 here. What do you do to the other side? You add 1? Yeah, see, it's not 1 you added. You actually added a negative 4. So you got to do this little number. And now 4 plus 4 minus 4 is 4. And this one, I'm just going to recopy this now. Y squared minus 4y plus 4. If I factor this, I get y minus 2 squared, followed by negative 4. Then what? What's this factor into?
X plus 1.
X plus 1 squared, gotcha. Okay. Can't have a 4 on the right side. What do we do? Divide by 4. Divide by 4. Divide by 4. And you get y minus 2 over 4 minus, what here? What happens to the 4s? They're out. It's over 1, in case if you want to see the number, it's 1. And this makes 1. Okay. Your job is to actually sketch that. And with 3 minutes left or 2 minutes left, I don't have time, but can somebody tell me the A, the B, the C? What's A? A is 2. What else do you know? B is 1. C is not that important in here, unless I want to get the focus on paper, but what would C be? Square root of 5. Okay. C would be certified, okay. All right. And now, my next question is it a transverse that's horizontal, or is it transverse vertical? Vertical. Okay, where's the center? Center is what? -1, comma, 2. About as far as I'm going to get, guys. We might just wrap this one up tomorrow. We can start about right there and just finish. Now, what can you do tonight? You can get a good start on day 1. This is important to get off to a good start on a Monday. Okay, don't wait till Tuesday because then you're in trouble. We got a big worksheet on Wednesday. It's huge. It's going to take you a whole hour and wait. All right. Hopefully that made sense.
Oh, I'm so sorry.
Yeah. You're gone.